All right, so now we're going to write the names, or we're going to write the formulas of ionic compounds, binary ionic compounds. Really simple, basic binary ionic compounds. This is a really simple version of basically explaining how compounds form ionically. To do this, you're going to want a few things. This is where it can get a little confusing. You're going to want your periodic table, where you have all of the ionic charges listed for stuff. Like, I'm going to give you an ion chart next week that says the ionic charges of everything. But for right now, it's really important that you actually have the ionic charges in front of you for all of the different elements. It's very important that we have that for this basic thing. Now, the worksheet I'm going to give you, it has them listed, but it's important for the examples and stuff that I'm going to be showing you. So basically, binary ionic compounds, the deal with them. Ionic compounds, so ionic compounds form, when they form, they're always neutral, are neutral. So that means you're bringing two ions together that cancel out in charge. So you watch the video on ionic bonding, showing how there's this transfer of electrons happening. And this transfer of electrons leads to the charges, it leads to them attracting and sticking together. But the big thing for ionic compound, like writing the formulas out, is making sure that they're neutral. Now, what does that mean? That means that, let's look at a really simple example. Let's say you're going to combine sodium, which is +1, and chlorine, which is -1. Those are the ionic charges. And if you're like, what in the world is that? Remember, sodium is a +1 charge. Chlorine is a -1 charge. They're going to bond together, and they're going to just combine to form NaCl. Now this one usually makes pretty good sense because you're like, oh, okay, so I've got a +1 charge here. You combine it with a +1 charge from the chlorine, what happens? They cancel out. Like +1 and -1, they add up to what? 0. They add up to nothing. So it's a neutral compound. You're good. But it'll get a little more complicated, and then next week we'll make it much more complicated when we involve ions, like polyatomic ions and transition elements, and it's way more fun then. But this is the basic idea here that you need to understand. All right, that things form compounds ionically. They're neutral. The big confusion that kids have here is that for this one, there's no prefixes. So the big thing, there are no prefixes. All right, covalent is prefixed. Di, tetra, penta. No prefixes are used for this stuff ever. So you're never going to see a prefix. You're not going to need a prefix. You don't need them because you can just figure out the formulas easily. All right. So the way it'll work, the way these form compounds, let's just do a quick example. So let's say we're going to combine lithium and nitrogen. So example, these are all just, the way to learn these is just through many examples. So lithium and nitrogen. So lithium, if you look it up, is a +1 charge. Lithium is +1. Nitrogen is -3. So we got a +1 and you got a 3-. Now, these things are going to form in a compound. But the thing is, the way they're going to form compounds, it's got to be neutral. And you can assume that you have as many atoms as you need to form a compound. It's not like there's just literally one lithium atom and one nitrogen atom. There's a countless number of atoms bonding together. You just want to make it so that the ratio is correct. Now, the ratio here, in terms of doing this, is pretty easy to figure out once you see the pattern and you realize it. But initially, it can be a little confusing. So let's say we did it like this. Let's say I wrote LiN. Well, okay. What's the overall charge on nitrogen? It's a -3, right? So this nitrogen, this is a -3. What about this lithium? It's a +1. If you write that out like that, what's the overall result of this thing? So the overall result is that this is a -2 ion. Because, -3, +1, they add up to -2. I put the negative after the 2. That's just how you write ions. You got to get used to it. It's weird, I know. But that's just the way it works. So this formula is wrong. This is wrong. I can't even spell wrong. So wrong. The reason is it is not neutral. Wrong because it is not neutral. Neutral means no charge. All right. So maybe we'll go back and rephrase this. Our neutral, no charge. All right. So all right. So now here's what you can do. You can add more atoms now. So lithium now. What if we had 2 lithiums there? What if we had 2 lithiums there? And a nitrogen. Well, now you've got, so you got 2 lithiums. I'm going to write it out like this. So you got a lithium, it's a +1. You got another lithium, it's another +1. And you still got a nitrogen, which is a -3. So, you know, this is just another example here. What does that add up to? So lithium is +2, nitrogen is -3. This adds up to a -1 ion. This is still wrong because it is not neutral. So both of these, so wrong, both wrong. So wrong. So instead, let's keep going, and you see the pattern here, I hope. Oh, what if we put a 3 there? What if we have 3 lithiums to 1 nitrogen? Well, now you're like, oh, okay, so lithium, now I've got a +1, +1, and another +1, and then my nitrogen is still a -3. So what does +1 + 1 + 1 add up to? And you're like, oh, it's 3+. Cool. What does -3 add up to when added to nothing? -3. What do those two do? They cancel out. They cancel. Neutral. So this is correct. Neutral. So this is your correct formula. Now, that's the theory behind it. Thankfully, there's an easier way to do it, though. I mean, once you see the pattern, it's ultra simple. So let's look at like simple version, simpler way to do it. So I don't make notes on electron configurations. Let's do it like this. A simpler way to do it now is just the crisscross method. Crisscross method. I believe there was a singing band called Crisscross a long time ago that lip synced and got like, I don't know, nobody liked them or something. I could be wrong. I think it was from like the 90s or something. Oh, I just got ink on the desk. Anyway, so pretty much just look at it like this. So to go back to that example, lithium is a +1 charge. Nitrogen is a -3 charge. Here's all you got to do. Figure this out. Whatever the charge on the negative ion is, it goes down there. But you just write the number. Whatever the charge on the positive ion is, it goes down there. But again, just number. No actual positive or negative charge. So I'm simply saying you take Li and you just write the 3. You just take the number. So you just switch the charge numbers. But you don't include the charges. So switch the charge numbers, but not the positive or negative. And then what's n going to be? It's going to be a 1. You don't need to write the 1. If something is a 1, you can just write it as Li3n. And there you go. That's the crisscross method. This will always result in a neutral ionic compound. Nothing to be concerned about. What was I going to do? I was going to do more examples. I don't know why I was reaching for something. So let's do another example now. We can make it more complicated if you want. It's all the same. So let's say we've got, let's say we're going to combine iron. And I'm going to tell you that this iron is +3. And we're going to do oxygen. So we're going to do oxygen and iron. Now oxygen's a -2 charge. Iron, we know, I'm just telling you is +3. It's in this middle group, the transition elements, where I haven't told you the charges yet, which we'll get to next week. So I'm going to rewrite them like this. So this will be 3 plus. Oxygen will be -2. And then all you do, you just crisscross. You take that 2 and you put it down there. You take that 3, you put it down there. Then you write the formula, Fe2O3. And you're done with that one. Wow, wasn't that simple? That's it. I'm not kidding. There's nothing more to it. Well, there's always more to it. There's a little bit more to it. But that's the basics, all right? So that's how you do the crisscross method. And if you don't believe me, you can go and check it out. And you can do like, oh, so 2 times 3 is +6. 3 times 2 is -6. So they cancel out. They add up to 0. They're neutral. The only thing you need to be aware of when doing this is that you have to simplify these. You can simplify ionic compounds. You never simplify covalent compounds, ever. But you simplify ionic compounds, all right? So, for example, let's say we are going to have, so calcium is +2, and then sulfur is -2. Let's say we're going to combine those two together. So let's say you crisscross those. You're going to end up with Ca2S2. So you will simplify ionic compounds. That means you keep the ratio the same, but you simplify the number. So like 2 and 2 can just be simplified to CaS because they can both be divided by 2. So that becomes that. All right. That's the only thing you really got to be aware of when you're doing ionic stuff. Now your work, you're just filling out this chart. So a few things about ionic compounds. So and the way you're going to fill this chart, it looks like a lot, but good God, it's so simple once you just start do a few. I mean, you know, you're literally just going to, you're just going to crisscross them and you're going to fill it out. It's as simple as that. So like Li, you got N. So you can crisscross. If there's nothing there, it's a 1. Since it's 3, you're just going to do Li3N. I mean, that's the example problem we just did. But then you'll just keep going with this. A few things to make a note of, though. The positive ion is always written first. Always. A positive ion is called a cation. That's just its name. It's called a cation. It's always first. The anion is a negative ion. It's called an anion. It's always second. So the first positive is first, negative is second, always. All right. I'm going to make a little note of that right here. So positive. So it's called. So I'm going to even. So the positive cation. That's what it's called. That's the name for it. It's a silly name. Positive cation is always first. The negative ion, which is called an anion, is always second. And it's very important you remember that when you do these problems. So you'll just go through and you'll be like, all right, I'm going to go through and I'm just going to do everything. So like random other example. So you'd have like BeO. The reason you have Be2 and O2, those would cancel. Like they would simplify and you just write BeO. All right. And that's it. So just get the hang of doing this. Just practice this. And that's all you got to do.